Hello everyone and welcome to my YouTube channel Chemistry Unfold. As you see in this complex, the d electrons is d7, nickel is d8. So what you see, the one which has lesser number of d electrons in it causes higher splitting than the one having more d electrons. Okay. Now coming to principal quantum number n. What happens, the general trend in the periodic table, what you know, that as you go down the group, the size of the d orbital increases. Same way, cobalt, rhodium, iridium, they belong to the same group. And as you go down, their size increases. So as a result, what happens is the splitting in iridium, which is a 5d, is more. Their gap is more. As a result, you see that it splits to a higher extent as compared to cobalt and rhodium. Now that comes to nature of ligands. If you have, say, suppose a weak field ligand, consider iodine. What it does is that it splits small, and a strong field ligand like carbonyl, it splits higher. What happens is, say, suppose you have a D4 ligand. D4 species will first filter down orbitals, and later on, since the energy gap is less, it will go on top. But if you consider a strong field ligand, this energy gap is very big. So that same D4 complex, instead of going up, will start pairing. Understood? Because the energy gap is big, it won't go on top. It will rather prefer staying down. That is the nature of ligands, which affects the splitting. Weak field ligands, it causes a small degree of splitting. Therefore, the electrons can easily go on top and they form high spin complexes. Whereas a strong field ligand, the energy gap is more. So that particular electron does not want to spend that much energy going on top, so it rather prefers pairing up. So it forms low spin complexes. Then comes the number of ligands. The magnitude of crystal field splitting increases with increase in number of ligands. Now you know octahedral has 6 ligands. Tetrahedral has 4 ligands. So the splitting is seen in higher in case of octahedral. Therefore always remember, tetrahedral complexes always gives rise to high spin complexes. But for octahedral, that depends on the ligand. If you have a weak field ligand, it will give rise to high spin complex. But if you have a strong field ligand, it will give rise to low spin. But now comes the trick. If you have a square planar ligand, what will happen? Square plane also has 4 ligands. Tetrahedral also has 4 ligands. But the catch is that square planar ligand causes a much higher splitting as compared to octahedral than compared to tetrahedral. Say this is for square planar, this is for octahedral, and this is for tetrahedral. So if you want to see the order of splitting order of splitting for square planar is most. Then comes the octahedral, and then comes tetrahedral. Now if you see an octahedral splitting, that depends on the ligand. If you have a weak field, then it will be energy gap will be less. If you have strong field, energy gap will be more. Thank you. If you like the video, please subscribe to my channel.